Alright, so while we're setting up, we are Team Cloud Tango. Two of us are from Flux from San Francisco, and Peter is from UCLA, so he's a host. What we're trying to do is very similar in problem-wise with what the robotics team was trying to do. The problem is that there's a lot of data around, there are a lot of tools around, they're all completely disconnected, disjointed. The data from the field never makes it to a desktop of a of an engineer or of a designer sitting in a central office in a different city, right? And we're trying to bridge that divide, basically bridge the divide using some cloud fancy technologies. So specifically, what we were all very excited right here on Friday. All these people around had all this really cool Project Tango devices, and specifically thank you Cody and thank you Brock for lending us the hardware. So we just played with it and okay, what can we do about this whole thing, right? How about we take a Project Tango device, connect it using the Flux technology through cloud to a bunch of instances of, specifically we had Peter, who's crazy Grasshopper wizard, so we're okay, let's connect Grasshopper to Tango, right? Using Flux, and maybe then connect Grasshopper to another Grasshopper using Flux, right? So we started with making some photos of one of our colleagues, Jen. That's her cloud, point cloud. That's her mesh, which we made using that point cloud, and yeah, they could work, right? So next we moved on to actually checking how does it look compared to Kinect. And Kinect, to be fair, is high resolution device. It actually gives you a better picture, but it's not as portable. It's not something you can take on the field as easy. There is no battery. You need a laptop. It's kind of awkward walking around this Kinect, scanning walls of a building that's being constructed right now. So we decided to focus still on Tango. So what we did, we built a map which just captures the current view, the current frame in a point cloud, right? Then if you press the button called to Flux, what it does, it packs it up and sends it in real time to the Flux servers, right? That's what it looks like. That's a wall scan using that program already uploaded into Flux. It's available to anyone who's using that platform, right? Then we automatically, in real time, are pushing the data into a Rhino instance, which is running a script which accumulates those frames. So it's basically stitching a scene out of a frame someone is going and shooting or using a Tango device, right? What we're doing next is we take the whole scene and push it back into the Flux platform, and through that into another Grasshopper instance where Peter was doing his magic, detecting edges and surfaces, trying to make walls out of this crazy swarm of points that we're throwing at him, right? So yeah, what it ends up being Tango to one Grasshopper, which is accumulating the whole scene, to the second Grasshopper, which was actually trying to detect walls out of those points on the field. And all of that actually doesn't have to be in one room at all. It can be on different continents. All of those three players can be sitting on different continents, and some of them nowadays even on a plane, right? Making all of this work happen simultaneously in real time, right? So we have, and we will try to make a live demo happen, and meanwhile the judges or anyone can come up with interesting questions, right? Okay. So I'm gonna go in the back of the room and try to scan the back of the wall of this room if I can, and push it onto this computer.
Actually, it should use the infrared. We think it will work in the dark. And I might have to narrate as Max is heading to the back of the room by the doorway.
Yeah, it's going to be interesting.
So this is the script that brings in the data from Flux. He's pushing it up to one of our projects. And then, let's see. these grasshopper nodes bring it in from Flux and then bake it into Rhino. So we'll see if this updates. You ready, Max?
Yep.
Yeah. That's good.
Oh. Yeah. I think we might want to do another one, Max.
Alright.
So the way the Tango, so part of this is, it has to do with, the Tango is doing the simultaneous location and mapping where it uses the images and the gyros to build up its position as well as the point cloud. And so it's up to the Tango to keep the frames consistent in the same space. And then we're just streaming in that data transformed into the world position. So if the Tango doesn't calibrate well, then some of the images might not be perfectly aligned. But yeah, it's just
You can see the texture of the wall.
Yeah.
Pretty cool.
It's nice.
so it's pretty detailed. There we go. Now it's aligned a little better. So you can see those two scans coming together. He's adding more information.
Yeah.
Nice. So as the Tango keeps going, it builds up a better and better model of the room. And it gets more accurate about its position. Yeah, so I think that's the doorway.
Yeah.
Cool.
Great.
And then
Yeah, try to
I'll just look here at the, so this should be the last frame that you captured.
Yep.
So that's on our web platform.
In the cloud.
Each of these represents an entry in the database. And this is the one that he's got the current Tango is connected to this key.
Oh yeah, I could actually replace it with something.
No, that's fine.
Wait.
Oh yeah, you want to take another shot.
Yeah, some of our host, let's see.
Oh, you got a nice view of the corner there.
It's low radiation, don't worry.
Just lasers. That's
Right.
fine. Do that.
There he is.
There he is.
You turned it the
I turned a little bit on the sideways.
Turn the tablet.
There he is. Yes.
That's awesome. Oh, yeah, you guys
That's cool. That's cool.
So yeah, you want to show the Peter? You want to
Okay.
show your project?
So what we were trying to do then afterwards is to take this point cloud data and turn it into surfaces that are measurable and in some ways can be used in applications where, for example, on manufacturer and construction site, workers could scan components and evaluate whether its dimensions or any other kind of scalar properties. So I've been working on turning these point cloud data into mesh surface and then trying to find zones in these mesh surface that are planar.
Okay.
So sampling.
Doesn't matter.
Oh,
It's a project.
Okay. Oh, then we can cancel it. You're not doing any live data, right?
No, actually you can cancel.
Yeah. There you go. So, good luck on a small screen.
Okay. So here you see one of our scans, which is one of the trash cans. And how this works is there are a few of these sample objects that you can try to approximate in the center of one of these faces. And it would sample a few faces around, and based on their normal direction, it would try to assume a plane and try to collect other points that might be on this plane. So if I drag this ball to one of the other kind of
Use the gumball.
kind of odd.
It's missing some kind of plugin.
Yeah, I put a point there to make it easy. it's going to move it then. So, as you see, I snapped it on this face now and generated another plane here. And this, you can move this.
Do you want to select that element in Grasshopper so it's green? There you go.
So it's trying to snap to certain faces.
That's basically like simple detection.
Right.
Yeah, there you go.
Okay.
Yeah, it's good.
Right enough, I guess. Yeah.
Go. So we have one more slide left. Yeah, that would be the team right there, made using our tools. Right, guys, thank you for listening, and any questions?